So, for today, we're going to start in on chemical bonding. I will be honest with you, I also am skipping the periodic table because I just don't want to talk about periodic trends. It ain't fun. There's like 9 different trends, and then I cover them, and then I throw like 3 on a quiz. And you get all mixed up, you just miss points. This isn't good. I had somebody come to me today and ask me a question, and I'm like, oh gosh, if that's the question you're asking at this point, God help me, because this is bad. See next, our chemical bonding. So we are going to focus in on, I'm just going to give you all 4 types of bonds. Hopefully you've heard of them before. But first one is ionic bonds. The key with ionic bonds this forms between a metal and a non-metal. After ionic bonds, we have what I like to call nonpolar covalent bonds. These form between a non-metal and a non-metal. We have polar covalent this forms between a non-metal and a non-metal. Then the last one we'll look at is metallic bonding. These form from metals. So this is just a general overview of what we're going to be looking at within these different types of bonds. Breaking them down a little bit. So first starting with ionic bonds. The key to this is the first word. It forms between 2 ions. Well, it can be 2 or more, but pretty much you're just looking at 2. We're just going to focus in on a bond, and a bond's just between 2 elements. And let's just say 2 ions. We're going to keep it simple. So in this, you have 2 different types of ions that you'll look at. And it's all down to their charge. So the first one we got is cations. These are positively charged ions. Now, this is where this comes from, is on your periodic table, it'll break it all down for you. So within this, I'm going to show a relationship between lithium and neon. Alright, so here's an orbital notation of lithium. Here's an orbital notation for neon. And this is kind of the thing like what you're looking at. When you're talking about ions forming, is everybody is trying to get something called a full octet. And I'll go more into this in a second. But a full octet is just their full outer shell. So when we're talking about the full outer shell, what comes after 2p? Hopefully you guys remember is 3s. So this is where we see the difference, is we went from the second energy level to the third energy level. Within this, elements are lazy. They want to do just what's simple and easy. It's kind of like this TikTok I watched last night. No matter how you feel about the halftime show, but whenever the Weeknd was on the field and they were sitting there with their white mask on and everything, somebody made a joke and TikTok was all on, oh my gosh dude, the halftime show's about to start, we're about to be late. And you see this guy like running out wrapping toilet paper around his head so that his head is white for the halftime show. I thought it was kind of funny. But they were being lazy. They didn't even get a mask. In this, elements are the same way. So here's what you see for the lithium. If lithium wants to get a full outer shell, lithium has a choice. Lithium has one electron in the second energy level. So what lithium can do is it wants to get 8. If it is going to get 8 in the second energy level, it has to pick up 7 electrons. Or it has a choice. The first energy level is already full. So if it lost an electron, and this electron right here just went away, then it would have a full outer shell. Is it easier to pick up 7 or to lose 1? It's easier to lose 1. So in this case, this is what lithium will do. Lithium will find somebody, and they will just give it away to them. It's kind of like, you know, that high school sweetheart relationship where it looks and goes, oh, here's my heart, I love you. And lithium will join up with someone like fluorine. So when you look at fluorine, Here's the orbital notation for fluorine. This is what you'll see. Now it's the same thing. What would come next after the 2p was 3s. There's nothing there. So for fluorine, if you look at second energy level, I can talk today. If you look at the second energy level, when you're looking at this, fluorine has a choice. Its first energy level is 4. But if you look at the second energy level, it has 1, 2, 3, 4, 5, 6, 7 electrons in there. So it has a choice. Is it easier to lose 7 or gain 1? It's easier to gain 1. So this is what will happen. Fluorine's walking down the hallway. Lithium's walking down the hallway, properly socially distanced apart, fully face covered, like 3 masks on. They got some safety goggles, and they're like, wow, fluorine is looking mighty fine. Fluorine is like, wow, lithium, you looking nice today. And this is what will take place, is lithium will be like, have my heart. And fluorine will be like, okay. So this electron will leave lithium. It leaves lithium and it comes down here to fluorine. Now, here's the thing. Before this whole thing takes place, lithium has how many protons? What's the atomic number for lithium? 3, which tells you protons. So lithium has 3 protons. Before this takes place, how many electrons does lithium have? 3. So it has 3 positive charges and 3 negative charges, so it's neutral. But here's the thing that will take place. That electron left. So does it have 3 electrons? No. It now has 2. When this takes place, lithium has 1 more positive charge than it does a negative, which means lithium has now formed a positive charge. It has now become an ion. It has now become a positive ion, or as we like to call them, cations. So then the second one you're going to look at are anions. Anions are negatively charged ions. So let's take fluorine for example. Look at good looking, fine looking fluorine down here. How many protons does fluorine have? 9. It has 9. Because it has an atomic number of 9. Before any of this happens, how many electrons does fluorine have? 9. Now, whenever lithium was like, have my heart, and fluorine was like, okay, it gains an electron. Since it gained an electron, how many electrons does fluorine have now? 10. So fluorine now has 1 more negative charge than it does a positive charge. So now fluorine has formed a negative charge. And this is what will happen whenever this takes place. Lithium now has a positive charge. Fluorine has a negative charge. And they now join together in holy matrimony, bonded forever through the electrostatic interaction between a positive and a negative charge. To put that in simple terms, what does opposites do? They attract. I got a positive charge and a negative charge. So they're like, nyeh, and they bond together. This right here is what an ionic bond is. It's just that electrostatic attraction between opposite charges. That right there is an extremely strong bond. Whenever you look at it, ionic bonds are our strongest bonds. They like flexing.
So will they suck like that forever, or can they get like a divorce?
Absolutely, they can get a divorce. It's not likely. It's extremely hard, but it can happen. And we'll go through and talk about ways that can happen. But it's not like that. Pretty much when they get like that, we kind of stick them like that. Leave them like that. A good example of this, another example, like lithium fluoride there would be sodium chloride. And you know what we like to use sodium chloride for? We put the salt and stuff on our food, make it taste good. And then the electrostatic interactions can take place, and that's what gives us the flavors and everything from it. We also will put salt on the roads so that they're not slick and you can come to school. It's very nice.
It's cold.
Any questions there with ionic bonds? So I want to focus in for a second on the idea of forming ions and talk about the octet rule. Key is octet. What's oct stand for? 8. So it's all about 8 electrons. The octet rule is all about filling the outer shell. They want a full outer shell. There's different ways that they can get this. They can get this by losing or gaining electrons. They can also get it by sharing. Electrons. We'll talk about that later on. But the whole premise and purpose of this is they're trying to get 8. Now, the periodic table was broke down perfectly for you on this. Your first column has 1 valence electron.
What's that mean?
Valence electrons are the outer shell electrons. So these are the guys that are just stuck on the outside. They're the outermost. So breaking that down based off the principal quantum number, which is N, which tells you energy level. So if you ever looked at it and you have ever wondered why whenever we went through and I told you for S and P, N is equal to rho. But for D, N is equal to rho minus 1. And F, N is equal to rho minus 2. The reason we did that, how many electrons can go into an S subshell? 2, thank you. I don't know if I'm just boring today or you guys are still not awake. How many can go in a P subshell?
2.
What's 6 plus 2?
8.
How many valence electrons are they looking to get?
8.
On the periodic table, I know I'm jumping ahead, but there is one special group at the very end, the 18th column. Does anybody know what they're called?
The weekend?
No, close. Noble gases. Everyone wants to be like the noble gases. So in this, periodic table is literally built for you to help you with this. We have the second column has 2 valence electrons. This is where there's a change though. Whenever you get in the third column, you get into the D block. The D block is weird and freaky, and we just don't worry about them. We are strictly going to focus S and P block, our main elements. So we don't deal with the D block in terms of this. We'll deal with the D block when we get down here in metallic bonding. So in this, we jump to the 13th column, which starts us on the P block. Now this is a thing where the periodic table is just like, wow, that kind of worked out nice. Because the 13th column has 3 valence electrons. 14th column has 4 valence electrons. What about 15?
5.
Man, look at you, you're picking up fast. They got 5 valence electrons. 16th?
Is it 6?
Y'all are doing so good. I'm so proud. Y'all are going to get an A on this next quiz. I'm telling you, I feel it right now.
Don't think so.
Let's just stop. Like, this is enough material. Let's just quiz on this.
No. 17th?
5 on 7.
My goodness.
And the 18th has 8, right?
My God. I'm so proud. You know what? We could just stop right now.
Bonus points.
I had a kid that literally every day would come into class and ask for bonus points. Every day she asked.
How do you do?
And it got to the point that I literally had a kid that cracked a joke about her and just walked in and would look at me and say, Mr. Hall, I'm breathing today. Can I have bonus points? I'm like, no. So yeah, shut up. Every day we crack jokes. Anyway, y'all got 8 valence points. Valence electrons. Not valence points. And this is where the periodic table is built nicely for you. Because not only will it do that for you, but it will tell you what ions they will form. What I'm saying, first column has 1 valence electron. So we're trying to get to 8. Is it easier to lose 1 or pick up 7? They will lose 1. Second column, they have 2. So is it easier to pick up 6 or lose 2? They'll lose 2. 13th column has 3. Easier to lose 3 or gain 5? lose 3. Now the 14th column is weird. 14th column really doesn't like to form ions. 14th column, they like to form covalent bonds. So we don't worry about them. We kind of just want to leave that blank. And then we get the switch. The 14th column is where it switches. Because when we get the 15th column, has 5 valence electrons. It's easy to lose 5 or gain 3.
Gain 3.
So they will gain 3. The 16th column, easier to lose 6 or gain 2.
Gain 2.
Gain 2. Look at y'all doing so well today. 17th, lose 7 or gain 1. Then the 18th column, they already got 8. So they don't want to do anything. They just want to be them. It's like everybody wants to be them. You know, like the guy that took off and was streaking during the Super Bowl yesterday. It's like, wow, that's more entertainment than on the Chiefs' offensive possession we've seen in a long time. This is what they'll do. But now in this, they will also tell you the charges that they'll form. So in this, breaking it over to the periodic table, this is what you're looking at. So we got the columns here. The first column will lose an electron. If they're losing an electron, they're losing a negative charge, so they will form cations with a +1 charge. The second column lose 2 negative charges, or they form cations as a 2+ charge. You're going to see me put the, I guess I should do it right. You're going to see me put the charge afterwards. The reason we do that is you guys will learn about oxidation and reduction numbers later on in this class. We always put that charge first. So we don't worry about the D block. So then we got the 13th column. They lose 3 electrons, so they'll form a 3+. 14th column, they like to form covalent bonds, so we're not worried about them. The 15th column is where it changes to where they'll pick up charges. So here's where we'll see a 3 negative, because it'll gain 3 electrons. 16th column is a 2 negative. 17th is a 1 negative, and 18th column, well, they just kind of like, I'm cool and I don't need anything else. This is the breakdown for the U on your periodic table, where you can look super duper quick and you can tell me the ion that will form. So if I look at you and I went sulfur, what type of ion will sulfur form?
2 negative.
It'll form an ion with a 2 negative charge. What type of ion? Cation or anion? Form an anion with a charge of 2 negative. This will help you out later on. This doesn't make a lot of sense right now, but this is foreshadowing, because you're going to start grouping these things together later on, and you need to know the charge of those ions. Is there any questions? Okay, if you have questions, you need to ask.